In this video, we're going to discuss the average rate of change of a function. We've discussed lines quite a bit, and lines are kind of special. They have a slope that we talk about quite a lot, which measures the steepness of the line. And the thing that's special about lines is that that slope is the same for the entire line. So if you want to calculate the slope of this line, it doesn't matter whether you use these 2 points or whether you use 2 points down here or some other 2 points. Any 2 points you use, you'll get the same value of the slope because the slope is consistent across the whole line. That's only true of lines. It's not true of other functions. So if we have a function that is curved, that slope is going to be different depending on where we look at it. In fact, here we can see the function is decreasing, so the rate of change is negative, but over here it's increasing, so the rate of change is positive. And even up here it's more steep than it would be down here. So those values would both be positive, but they would be different. So what we do with functions that are not linear is we can calculate what is the average rate of change over a certain interval. And so to do this, we're basically looking at the slope of a line that would pass through 2 points on that graph. So if we look at 2 points here, then we can say, all right, what is the average rate of change of this function on this interval from a to b? And so essentially, we're looking at what is the slope of the line that would pass through those 2 points. So this is the secant line that passes through those 2 points on the curve. So we're finding the slope of that secant line essentially when we're finding the average rate of change on an interval. So for this function, which is a curved function, this function is going to look something like this. It's a parabola with a vertex at the origin. And so we're going to have a different rate of change depending on what interval we're looking at. So the first interval we're looking at is from x equals 0 to x equals 2. So this little interval here. And we want to know the slope between the points that have those x values. So first we need to find what are the y values for those points. So if we plug in 0 for x, we get 0. So we have the point 0, 0. And if we substitute 2 for x, we get 4. So we have the point 2, 4. And we're just then finding the slope between those 2 points. So subtract the y values, subtract the x values, and the slope of the line passing through those 2 points is 2. So that's the average rate of change for this function on that interval. All right, here we're looking from x equals 1 to x equals 4. So again, just finding the slope between that pair of points there. So we need to know what are the y values. So if we substitute 1 into the function for x, we get 1. And if we substitute 4 for x, we get 16. So those are the 2 points that we're looking at. We're just finding the slope of the line that would pass between those. So subtract the y's, subtract the x's. I got a little ahead of myself there. So the y value or the x values are 4 and 1. So then 4 minus 1 is 3. And 15 over 3 is 5. All right, so we got two different rates of change because we're looking at two different intervals, and since it's a curve, it's not going to have the same rate of change uh, the whole time. Here we'll probably get an even different answer yet. So when x is -3, then the function value is 9. So we have the point -3, 9 over here somewhere. And then we have the point 0, 0 again. So we're going to subtract the y values and subtract the x values. And we get -3 for the average rate of change on that interval. This time it's negative because on this part of the graph the function is decreasing. So we have a secant line with a negative slope there, whereas on the right side we had secant lines with a positive slope.